So for example 3, we want to suppose that A and B are angles in standard position and that the sine of A is positive 4/5 and A is between pi over 2 and pi, and the cosine of B is negative 5/13 and B is between pi and 3 pi over 2, and we were going to find 3 things about it. The first of which is the value of the sine of A plus B.
Okay.
So, to find sine of A plus B, I have to expand that out, right?
Yes.
And so the first thing I'm going to do is expand it. Probably not like that. We will expand it to the sine of A times the cosine of B, plus or minus
Plus.
the cosine of A times the sine of B. Okay. And then we're going to substitute in what we know and go figure out what we don't know so that we can come up with an answer for this. Total, we need 4 things, and I gave you 2 of them. Did I give you the sine of A?
Yes.
So that is, all right, we'll substitute that in. Did I give you the cosine of B?
No.
Yes.
Yes, I did. So that's negative 5/13. But did I give you the cosine of A?
No.
So that's missing. And did I give you the sine of B?
No.
That's missing as well. So the question becomes, how do I find those 2 values based on what I know? Now there are 2 ways we can do this. We can either use the Pythagorean identity, the sine squared plus cosine squared of an angle always equals 1, or we could draw triangles and use the definitions, y over r, x over r, y over x. Doesn't matter to me. Which would you like to do?
Triangle.
Triangle? Okay, so we have to do each angle separately. First thing I want to find is the cosine of A, so I'm going to go draw a triangle for angle A. And we know that angle A is in which quadrant? It was given.
2.
Yeah, it says it's between pi over 2 and pi, which means I need to draw angle A in quadrant 2. So over here somewhere is angle A. And the one thing I know about angle A is that its sine is 4/5, and the sine is y over r, or opposite over hypotenuse, which in this case would be 4 and 5. And I can use that information to solve for the x value.
3.
3, because it's a 3, 4, 5 triangle. But is it positive 3 or is it negative 3? It's negative 3 because in quadrant 2 the x value is negative. So you can use the Pythagorean theorem, but we just happen to know that that's 3, right? Because it's a Pythagorean triple?
Correct.
Correct. Okay, so we'll go and we can figure all that out. We have 4/5 times negative 5/13 plus, what's the cosine of A now that I have that triangle?
Negative 3 over 5.
Negative 3 over 5, yeah. So we can substitute that in, negative 3 over 5, which in this case is x over r, or adjacent over hypotenuse. That leaves us wondering about sine of B. So I could either use the Pythagorean identity, sine squared of B plus cosine squared of B equals 1, or I could just draw a second triangle for me. I prefer the triangle method. Is that okay?
Yes.
Right. What quadrant is angle B in? That's the 3rd quadrant, right? Between 180 and 270. All right, so we're in the 3rd quadrant. So we'll draw a triangle down here. And what do we know about B? We know that B's cosine is negative 5 over 13. So that's the x over the r, or the adjacent over the hypotenuse. And that leaves us to find this y value. So we know that x squared plus y squared is equal to r squared. So I think you are correct. It is positive or negative 12, and that just depends on the quadrant. Which is it?
Negative.
Negative 12. And then we can use that information to find the sine of that angle. The sine is opposite over hypotenuse, or y over r, which is negative 12 over 13. So it's just a lot of work, but we can find it all, right? Okay, so I'm going to pause for a second, let you tally that up and see what the final answer is. Okay. So what'd you guys get? When we do these 2 together, we get negative 20 over 65. And when we do these 2 together, we get positive 36 over 65. And that combines to 16 over 65. Is that what you guys got?
Yes.
Yes.
Perfect. And that's how we find sine of A plus B. There were several in the homework from 5.3 that were very similar to that. So if you were having some trouble with those, you should be able to go back now and complete them. I think they were like 51, 53, right along in there. Make sense?
Mm-hmm.
Now we want to come through and we want to take the same problem. We want to find the tangent of A plus B. So we still know the same things. We want to find the tangent of A plus B. Now, one way to work this problem would be to use the two we were given. Let's see, we were given sine of A is 4/5, and we were given cosine of B is -5/13. And we also know the cosine of A and the sine of B because we just found them, right? So we could find tangents by doing sine over cosine. Does that make sense? Okay. But we don't know the sine and the cosine of A plus B. We only know separately of A and B. So we still have to expand this out. Does that make sense? Okay. So let's expand it. We have tangent of A plus tangent of B divided by 1 minus tangent of A times tangent of B. Unfortunately, I don't know the tangent of either angle. Now, based on what we knew before, we said that we found the cosine of A to be -3/5 from the slide before, right? And we found the sine of B to be what? -12/13. Okay, but that's all work I had to go do for that previous problem. Does that make sense? Okay, but if I had those four things, I could find the tangent of A by just simply saying sine of A divided by cosine of A. Do y'all understand that?
Yes.
And so very quickly I could, flip that and multiply, and I could see that it's -4/3. I would like to treat this problem, however, like we started from scratch. We didn't know, let's pretend we didn't know these two things. How would we find the tangent of A and the tangent of B if we didn't know those two things? It's a great question, isn't it? Well, how did we find these two things right here on the last slide?
We went and made a triangle.
We went and made a triangle. So if we were starting this problem from scratch, couldn't we still go draw a triangle? Yeah, we could do that. So we could draw a triangle for A, and it's in quadrant 2. And we did it a second ago, so it shouldn't take us very long. And that's the Y and the R, and we found this to be -3. What's the tangent of that? Y over X, which is -4/3, and that's for angle A. So that's the same as we would get if we divided the sine of A by the cosine of A. So -4/3 plus, and I need to do the same thing for B. If I draw a triangle for B over in quadrant 3, all right, and we started with -5/13 as the cosine, and we found that this value was -12. That means the tangent of that would be -12/13, correct? Okay. So that's the reason I would prefer to do it this way is that on a quiz or test, I'm usually not going to ask you to find both. I'm usually only going to ask you to find one of them. So we want to treat it like we're starting from scratch. So we say -12 over 13.
It would be 12 over 5.
Oh yeah, you guys are right. Thank you. -12 over 5. Negative Y over X. So really it's positive, right? Which makes sense because we're in quadrant 3. So, having trouble. Okay. I don't trust myself. How's that? All divided by 1 minus tangent of A times tangent of B. So here's where we have a bunch of fractions together. We have -4/3 plus 12/5 all over 1 plus 16/5. I clean up this fraction right here, these two. I reduce this to a 4, and I get 16/5. Okay. And I'm trying to do it like we don't have a calculator. I realize that if you were going to type this in your calculator, this isn't the way you would do it. But you guys are still so bad with fractions that I'm really trying to practice with you by hand. Okay, so that's how I would do it if I wasn't going to touch a calculator. Then I could multiply everything through by what? Common denominator of 15. The common denominator of 15, I can multiply the top and bottom and distribute it in. Multiply by 15, multiply by 15, multiply by 15, multiply by 15. And that would bring me up to, I don't think I want to. Let's erase this. What does that bring me up to? Let's see. Yeah, the 3 and the 15 simplify to 5, and -4 times 5 is -20, plus The 5 and the 15 simplify to 3, and 3 times 12 is 36, all over 15 plus 48.
Yeah.
Does that make sense? Okay. So that gives us positive 16 over 63. Did you guys get that?
Yep. See.
Yes? Okay, great. That's the tangent of a plus b. Okay? Tangent of a plus b. Now I have one other question for you. Is everybody ready? My final question for you is, based on what we've done so far, and it is going to require you to think about what we've done. It's not something you could do from scratch, okay? Based on the two things we've done, take a minute and try to decide what quadrant you think the angle A plus B has to be in. I'll pause and give you some time. What'd you guys decide? It has to be in quadrant 1. Okay, so it has to be in quadrant 1, and the only way you knew that was because the sign of it was positive 16 over 65, and the tangent was also positive 16 over 63. And the only way for sine and tangent of an angle to be positive is if they're in quadrant 1. So we'll stop there, and then I think we actually only have one more example.